afternoon, everyone. I am VAISHALI GORE, research scholar from India. I am going to present here today cosmological model, that is homogeneous BIANCHI type 6H stringless cosmological model with perfect fluid in general relativity. Outlines are, I will just give introduction, then construction and conclusion, then references used. As in 1916, Einstein given the general theory of relativity, which is one of the most remarkable achievements of science and foundation of cosmology, that is the study of universe. Louis Bianchi, a mathematician, given class of cosmological models known as Bianchi universe or Bianchi cosmological model that I am going to construct here. Then in the study of universe, string theory plays an important role because it describes all particles and forces in the universe. This is just one figure of string. That string theory, as I said, very important. Then investigation of cosmological model. So this homogeneous Bianchi type 6 string, we assume just here condition A is equal to beta b raised to n and string tension density lambda is equal to rest density. When we derived here deceleration parameter, we will give here value which lies between -1 to 0, and also some physical and geometrical features of that model are discussed. So this is the field equation for Bianchi type 6H matrix, where this A, B, C are functions of T only. And here energy momentum tensor is given by this Tij. So with this condition, Vi Vj is minus Xi Xj is equal to -1 and Vi Xj is 0. So with this flow vector, when I calculated that Einstein's field equation, we will give this equation. Then after, as we have here system of 5 equations with 6 unknowns, so we required here one additional constraint. So we assume that condition A is equal to beta b raised to n, so that equation number 10 leads to C is equal to alpha beta, and using this condition we find all these A, B, C, D. So I just keep this equation, and this is the line element 1 after putting that value of capital A, B, C, which is the function of T only. Then these are some physical and geometrical parameters of this model. This model starts with the Big Bang at T is equal to 0 and the rotation is 0, whereas deceleration parameter is given as Q is equal to, for N is not equal to -1. Interesting part of this deceleration parameter is for our model, that value is Q is equal to 0.77 for N is equal to 0.1, and actually it lies in between -1 to 0, and this Q is less than 0, that is accelerating phase we are getting. Then the expansion for the model, if you observe here this figure, then expansion is a decreasing function as n is greater than 0. Then we are getting here this approaches to 0 as time approaches to infinity, and expansion of that model stops when n is equal to -2. The next parameter, that cosmological constant, that is string tension density lambda. If you observe here this string tension density lambda, it is decreasing function as time increases, lambda tends to 0. Similarly, next parameter is volume. If we observe here volume, that represents the volume V of the universe. Initially, at initial epoch, that is 0, whereas the time increases, volume of the universe increases. This is Hubble parameter, that value decreases as time increases. Again here, if you observe here ratio of that shear and expansion, we are getting here constant value, and for n is equal to 1, that becomes 0, so the model isotropies. Conclusion part, this model starts with Big Bang at T is equal to 0. Deceleration parameter value is -0.77 for n is equal to 0.16. Then the scalar expansion decreases, whereas this expansion stops when n is equal to -2. Volume also increases as time increases, and Hubble parameter decreases as time increases. That ratio of shear and expansion, it is constant, and whereas that model isotropies for n is equal to 1. So these strings disappear from the universe at a later time, that is present epoch. Thus the model represents expanding, shearing, and non-rotating universe. So many exciting these are the references. Many exciting developments are on the horizon, and that cosmology can look forward to a rigorous and challenging future. So on the theoretical side, when there is a working theory of structural development, the most important progress will made. Which came first, galaxies or supercluster? Does matter stress the light? So using observational data, theoretical models can be validated. Thus, the subject of cosmology is very much open and very much interesting. Thank you.
Thank you, ma'am, for your wonderful presentation.
Thank you, sir.